Greetings and salutations. In this video, we will be learning about the quotient property of logarithms. Again, I think it's helpful to look at a numeric example and see it actually working. So if we take log base 3 of 27 over 9, and we're asking ourselves, what should this be equal to? The quotient property says that if you have a quotient that's the result of a division in your argument, you can actually write it separately as a subtraction problem. And now we'll see that in fact that is going to work. So that's the quotient property in action. If you look at what we've got on the right side here now, log base 3 of 27, 3 to what power equals 27? Well, 27 equals 3 to the third. 9 is 3 squared. So we're going to be taking these. This is 3. And 3 to what power equals 9? 2. So on the right-hand side, we're going to get the value of 1. If we look at the left-hand side, now let's reevaluate this. This is log base 3. 27 divided by 9 is 3. 3 to what power equals 3? 3 to the first power. So log base 3 of 3 is 1. You can see that, in fact, when we do it, we get the same values. I'm going to try it with a common log. So you can see it's not just with these numbers, and it can work with numbers that don't work out so beautifully. So if we look at this with the common log, we can just plug this into our calculator and we can get the output for it. 3 halves is 1.5, so the log of 1.5 is 0.17609. That's what we get if we plug it straight into the calculator. Now let's take a look at what happens if we take the same logarithm and split it up using the quotient property. It says it should be common log of 3 minus common log of 2. Common log of 3 is 0.477121. The common log of 2 is 0.3012999. I want to go out so I didn't have to round any of those zeros. If you punch this into your calculator, you're going to get 0.17609 rounded at that point. Notice we got the same things. So if we got the same output here, as we did here, for the two different ways of writing it, the two different ways must be equivalent. Okay. So that's it working into numeric examples. Now let's see if we can prove it using algebra. Now we're going to start this problem off, much like we did with the product property one, with the statement, we'll let m equal b to the x and n equal b to the y. Now since we're talking about a quotient, we're going to divide both sides of this equation by n and get m over n, which is going to equal b to the x over b to the y. Let's clean this up a little bit. M over n equals b to the x minus y. It's a little simpler to write, maybe. It'll definitely be simpler for working with later. Now what we're going to do is for each of these three equations, we are going to rewrite them from exponential form into logarithmic form. So converting this one We get log base b of x, of m, that's my argument, equals x. This one, log base b of n equals y. This one, log base b of m divided by n equals x minus y. And we have other ways that we can write x and y, because we know that x is equal to log base b of m. It means I can take this statement, log base b of m over n, that quotient, and I can substitute in for x and y. X is log base b of m minus y, which is log base b of n, giving me the quotient property of logarithms.